Hello everyone. So in this chapter we are going to see the enhanced entity relationship model. So our last chapter was about entity relationship model, but now we are going to see enhanced entity relationship model, which is the extended version of ER diagram or ER model. So the EER stands for enhanced entity relationship model, also can be known as extended ER model. So this ER model concept, actually all modeling concept from ER diagram that we talked about in our chapter 7. But ER model has also some additional concept. So in those additional concept we are going to see subclass, superclass, or specialization, generalization, categories, attributes, and their relationship, inheritance. Okay, so these are also fundamental to conceptual modeling. The additional EER concepts are used to model applications more completely and more accurately. So ER includes some object-oriented concept such as inheritance. Also, we are going to talk about a relationship. Also, this relationship known as is a relationship. All right. So as we know that if we are familiar with object-oriented concept, inheritance create a relationship between subclass and superclass, which is a relationship. So each entity type may have additional meaningful subtype. Okay. So for example, like we are talking about employee in our company database. Now we keep track of each employee, but we can also like further specialized employees into multiple special employee. So the categories could be, or specialization could be like that. So we may categorize employees like using like in three categories. Say some employees are secretary, some are engineer, some are technician. So here you can see that we are categorizing employees based on their job type. Or we can also create some other categories or specialization on employees, like as a regular employee or as a manager employee. So some employees are regular employees and some employees work as a manager in a department. Okay, so this manager is also an employee, but he is a special kind of employee who works as a manager in one department. Another category could look like, so say some employees here worked as per hour, or some employee works as a salaried employee. Okay, so this categorization is based on the employee's method of pay. Now here what I am doing, I am having a one kind of entity type. Okay, so and one entity type may have some additional meaningful subtypes, and this categorization or subtyping I can do that based on some attribute. The ER diagram extend ER diagram, okay, and that can represent some additional subgrouping, for example like subclass or subtype. So with ER diagram there are many different diagrammatic notation for each concept. All right, so we are going to see also some other alternatives, and there are also UML class diagram notation for subclass, which will also be presented in later in this chapter. There is an example how we are going to showing how we are going to show the different subgrouping from one specific entity type. So we are saying that we have an entity type employee. Okay, so each employee has this set of attributes: name, SSN, birth date, address. All right, now we are saying we are further categorizing employees based on some attribute. For example, we can categorize or we can create some subclass from employee based on their job type. So some are secretary, some are technician, some are engineer. Okay, now this is a totally different categorization. I'm saying that some employees are manager. Okay, so who is not manager, they are just regular employee, but some employees can be specialized as a manager who works in a department. Okay, who works in a department and who works as a manager of a department. Now I can further categorize employee also using another attribute, based on another attribute, like how they are getting paid. So some employees are salaried employee who has a specific attribute salary, and some employees are hourly employed who gets salary based on per hour. Okay, so here you are seeing actually three different specialization. So one specialization is based on the job type. So one is like whether he is a manager or not. Okay, so like is manager, and this one is based on method of pay. But this is totally different specialization. All right, so one specific entity like say John Smith. Okay, one specific entity of employee type means one specific employee can be a secretary, he can be a manager, and he can be also a salaried employee. So this is just a total different type of specialization. Now one specific entity can fall into different specialization. Okay, so the same employee can be a technician, a manager, or a hourly employee. Okay, like that. Now here how we are going to represent this specialization, you can see that. So we have a entity type, and from that entity type we can create using another level of hierarchy, we can show the specialization. So each entity has some general attribute. Okay, some general attribute or some common attribute means I am saying that each entity, each employee has this common attribute: name, SSN, birth date, and address. Now when the employee is specialized into a specialized attribute, for example secretary, so each of the special entity can have some distinguished or special attribute. For example, like typing speed is only the special attribute for secretary entity. Okay, now each secretary is also an employee. Each secretary inherits all the attributes from the employee entity. Okay, means secretary, each secretary is also an employee, so he has all the attributes that the employee has, but the typing speed only belongs to secretary. Okay, like here, so salaried employee has a special attribute salary, so this attribute salary only belongs to salaried attribute. Okay, so if John Smith is an secretary, okay, and a salaried employee, so the John Smith will have all the attributes that a employee has. Okay, name, SSN, birthday, address, and John Smith will also have typing speed because he is a secretary, and he will also have salary because he is a salaried attribute. He is a salaried employee. So each of these subgrouping, engineer, technician, manager, salaried employee, etc., will hold a subset of employee entities. Okay, so I can say that a engineer, there are couple of employees. Okay, so engineer will have contain a set. Now this set will be a subset. Okay, this set will be a subset of employee set. So I have say employee, I have A, B, C, D, E, all are employees. Now I am saying that B and C are engineer. Okay, so obviously all the elements of engineer will be also part of member of employee. Okay, so let's see technician. I have technician D and E. Okay, so all the technician, this should be a subset of the employee set. Okay, all the technician must be also an employee. So these each are called the subclass of employee. they will hold a subset of employee entities. All right, and it is called a subclass of employee. So engineer, technician, secretary, they all are subclass of employee. Okay, now here employee is known as a superclass. So the relationship, we are saying that employee is the superclass and they are the subclass. The relationship here are superclass subclass relationship. Okay, so employee secretary, employee technician, employee manager. It says that secretary is a subclass of superclass employee. Okay, manager is a subclass of superclass employee. There are also known as, it also formed a is a relationship. Okay, so it is based on a knowledge representation terminology from AI field. Now it creates a relationship between superclass and subclass. Okay, and this relationship is known as a is a relationship, and is a relationship here it has a direction. So it creates a relationship from subclass to superclass. So we say that secretary, which is a subclass, is a employee, which is a superclass. So is a relationship is the relationship from subclass to superclass. So secretary is the subclass and employee is the superclass. Then technician is an employee. Okay, then we can say from each of the subclass we can say there is a relationship from subclass to superclass. For example, manager is an employee, salaried employee is an employee, hourly employed is an employee. Okay, so an entity that is a member of subclass represents the same real world entity as the member of the superclass. Okay, the subclass member is just an entity in a specific distinct role. So we're saying that a secretary is an employee, means when we say that there is a subclass secretary, he is actually he is an employee of employee entity type. So here we have a superclass super entity type employee. So each of the secretary is an also entity of the employee type, but they are just the special entity type and they has a specific distinct role. The entity cannot exist in the database by being a member of just a subclass. There should be a superclass. Okay, a member of the superclass can be optionally included as a member of any number of its subclass. For example, a salaried employee who is an engineer belongs to two subclass. Okay, so one specific entity can belong to multiple subclass. For example, here we have an employee who is actually belongs to an employee entity which is a superclass, but also he belongs to two subclass. He is an engineer. Okay, so he is an engineer and he is an salaried employee. Okay, so these two are here these three are three different specialization. All right, so one specific entity can belong to more than one subclass. Again, another salaried employee who is an engineer and who is a manager. So he is going to belong to three subclass: in the manager subclass, in the engineer subclass, and in the salaried employee subclass. Now, it is not necessary that every entity in a superclass must be a member of some subclass. I can have an employee who doesn't belong to any of the subclass. Okay, maybe he is not either engineer, technician, or secretary. Okay, there could be an employee who is not either engineer, technician, or engineer. Okay, or I can have an employee who is not manager, he is just a regular employee, or I may have employee who doesn't belong to either salaried employee or hourly employed. Okay, now there are some actually constraint we are going to specify on in the whole subclass and superclass generation. Okay. So an entity that is member of subclass, that is going to inherit all the attributes of the entity as a member of its superclass. Okay, and all the relationship of the entity as a member of the superclass. So if I have the subclass superclass relationship, okay, so an entity that is member of subclass, they are going to inherit all the attributes from the superclass. So I have a here superclass employee. Each employee has name and SSN. That means all the entity, all the subclass are going to by default inherit all the attribute from the superclass. So here I have engineer and here I have technician. Okay, now the engineer and technician, they are going to inherit all the attribute and also the relationship. Okay, so let's see the employee works in a department number. So we can actually, we're going to represent that as a relationship between that represent a relationship between department and employee. So that will also represent a relationship between all the subclasses and the department. So for example, you can say that each engineer works on a department, or also each technician works in a department. Okay, so in the figure we can see that each secretary has actually all the attributes from the employee. Each technician has the attributes from the employee. These are actually the special distinct attribute for each of the subclass. Okay, so T grade only belongs to technician, it doesn't belong to any other employees. So engineer type only belongs to engineer. Okay, the pay grade only belongs to hourly employee. Okay, and the salary only belongs to salaried employee. But all the attributes from the superclass, they belongs to all the subclass. Okay.